Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod.
Hello viewers, in last session we have seen what a block diagram is and what are the elements present in the block diagram. In today's session we will see the block diagram reduction rules here. The basic purpose of this block diagram reduction rules are to reduce a complex system to a simple format. The very first rule here is combining the blocks in cascade. Now, this is block 1 G1C followed by a block 2 G2, where the input on this is A. Now A into G1 is nothing but output for this and nothing but input for G2. That would give us A G1 into G2 would give us the final output. This two block system can be reduced to a simple format of one block, that is nothing but G1, G2, where the input on this is A and A into G1, G2 will give us A, G1, G2. Two blocks in cascade can be combined to a single block, that is G1, G2. The second rule is combining parallel blocks. Now we'll see two paths in parallel, G1 here and G2 here. We have a summing point and this is the output path. Now if A is the input on this, A into G1 would give us AG1 here, A into G2 will give us AG2, AG1 plus AG2 will give us AG1 plus AG2. That is nothing but A into G1 plus G2. So these two parallel blocks can be made into a simple single block, that is input, and you have G1 plus G2. A is the input and output would be A into G1 plus G2. So these two parallel blocks are made into a single block, G1 plus G2. Now we'll see the third rule, moving the branch point ahead of the block. The basic reason for moving the branch point is to simplify the particular complex circuit. A is the input, this is the branch point, AG is the output. You're supposed to move this branch point or after this block G. Then this can be represented as G, where input is A. You're moving this branch point ahead, have the branch point here, then it is 1 by G here, A, AG. Now if A is the input, A into G will leave us with AG as the output, AG as the input here to this block, so AG into 1 by G would give us the same output A. When you move the branch point, G here is replaced with, here you need to add 1 by G in this particular path here. Moving branch point before the block, that's how I represent it. A is the input on this, AG. Now this is the branch point. Okay, you're supposed to move this before the block G, where A is the input, output is AG, then it's G here, AG is the output. When you move this branch point this side to this side, you're supposed to add G in the other parallel path here. Ahead of the block it's 1 by G and before the block it's G. If you do have any queries and suggestions, please comment in the comment box below. Fifth rule is moving summing point ahead of the block. This is the summing point plus where A is the input, B is the input here. A plus B is the input for this. A plus B into G is the output. Moving the summing point of the block to this side. G. This is the summing point. Plus. Summing point is moved from here to this side. B. G. A. G give us A G plus B G. That is nothing but A plus B into G. So A and B are the inputs here. Similarly, A and B are the inputs, and A plus B is the output here as well as here. Only thing, we are adding G in the other path. Moving summing point over the block. That is G. B here. A is the input on this. A into G will leave us with AG. B here. So the final output is AG plus B. Now we are moving the summing point before the block here. A 1 by G. B is the input here. That is nothing but B into 1 by G is B by G. A plus B by G is the input here. A plus B by G into G will give us AG plus B. We have moved the summing point here before the block. Earlier case, we have added G. Here it's 1 by G. The seventh rule, interchanging summing point. Plus here where A is the input and we have other input B. That would give us A plus B. We have one more summing point, plus minus here. Then C is one more input here. That would leave us with A plus B minus C. This to this place and this one to this place here. Plus and minus. The second one in the first place now. A is the input. C is the input here. That will leave us with A minus C. Then we have the second summing point, plus and plus. B is the input. That would give us A minus C plus B. That is nothing but A plus B minus C. So even by interchanging the summing points, there is no difference in the input and output here. Splitting summing points. This is the summing point where this is plus and minus, on which the inputs are A, B and C. A plus B minus C. You're supposed to split this summing point. One summing point into two. A and B are the inputs here. That would give us A plus B. The second summing point, this is plus and minus. This is C here. So it would finally give us A plus B minus C. Even after splitting the summing points, there is no difference in output here. So this is how we can interchange and split the summing points. The next rule, combining summing points. A is the input, where B is the input here. That would leave us with A plus B. Have one more summing point, plus M minus C. C is the input, that will leave us with A plus B minus C. These two summing points are combined together, plus and minus. A is the input here, B here and C here. That would leave us with A plus B minus C. So even after combining, you have same output. The last rule, elimination of feedback loop. This is a summing point with R as input C, followed by the block here G. This is the branch point. R is the input here and final output is C here. This is the feedback path. The signal feedback path is C. So C into H will give us CH here. Now here the modified signal would be R minus CH. So R minus CH would be the modified output into G. All this complex block is now being reduced into a simple single block. R is the input, that would leave us with G by 1 plus GH. The output is C here. Let's see how we derived at this G by 1 plus GH. But C equal to R minus CH into G. C equal to RG minus CHG. C plus CHG will give us RG. C is common, you get 1 plus H to G will give us RG. Output by input C by R with G by 1 plus GH. If it is negative feedback, G by 1 plus GH. Now you'll see a system where you have the positive feedback if R is the input C. In return path you have H. This can be reduced to R as input, G by 1 minus GH is the final transfer function in this block, and C is the output. You have to memorize all the 10 rules for reduction of block diagram from a complex to a simple format. The only confusion in the 10 rules is between the branch points and summing point. If you can memorize for the branch point, then you can easily remember the summing points, because if it is putting the branch point ahead of the block, it's 1 by G here. Now if you're moving before the block, it's G here. It is reverse if you go for the summing points. If you do have any queries and suggestions, please comment in the comment box below.
Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.